So you know how like functions have, how many remember studying limits of functions in their calculus 1 course and calculus 2 course? Yeah, yeah, Christopher remembers it. And you know, you would look at the limit of a function as a function of x as x approaches infinity. The limit of a function as x approaches 0. And we know, like maybe I'll just ask you this real quick here. Maybe I'll put this in black. So, but hold on, I want to have my little x, y, here's my function. F of x here's A, here's B, and let's say this is like there's no hole there, okay? Let's keep it simple, no hole. What is the limit of the function as x approaches A? Sure, it equals B. Good, everybody. And that's because you can approach B, you can approach A from the right or the left, and you wind up with the same value. And so in calculus, when you learned about limits, you had two-sided limits, okay? But how would you adapt this to a function f of x of y? What does it mean for a function f of x of y to have a limit? Well, let's go to the book and I will show you. Okay, so here when we talk about the limit of a function, whoops, hold on, I didn't want to do that. I don't know what I did there. All right, yeah, this is the definition of a limit. For a function of two variables. The limit of a function of two variables approaches a limit L. I want to be careful. As x and y, as if you look at x coordinate, if you look at xy coordinates, if they approach, as they approach the point, the coordinate AB, the function will have a limit so long as no matter what direction we approach, the limit's the same. So in other words, in order for a limit now to exist, you have to be able to approach the point AB in any direction and you have the same limit L. So examples are very helpful here. Examples are very helpful. Okay, let's look here. Okay, example 1. Show that this limit does not exist. Okay, so you had well, yeah, let's show this limit does not exist. So what they do is they say, well, we can approach the origin along the x-axis. We can approach the origin along the x-axis. And if we were to do that, along the x-axis, we're moving along the line y equals 0. So if we approach the origin along the x-axis, that means we're approaching the origin along the line y equals 0. And if we substitute in y equals 0, okay, for our function, we're going to get x squared over x squared, and that equals 1. So that means as you approach the origin from along the x-axis, that means the function is approaching 1. And if you were to graph this surface in MATLAB, and you were to, rotate the surface and approach it along the x-axis, okay, you could approach from the positive x-axis or the negative x-axis, you would see you'd be approaching a value of 1. However, suppose we wanted to approach the x-axis from a different direction. Suppose we wanted to approach from x equals 0. Okay? If you were to do it from that direction, well, you would put then x equals 0. You'd be, the y-axis is the equation x equals 0. So you would substitute in 0 for x in your function, and you would get then negative y squared over y squared, which equals negative 1. And so in that case, you're approaching you're approaching negative 1, and so that's a different limit. That's a different limit. So now the function f of xy equals negative 1 as you approach the origin along the y-axis. And so since you have two different limits, you learn this, if you have two different limits, okay, approaching, we're approaching the origin in two different directions, two different ways, and we get different limits, that means the given limit doesn't exist. That means the given limit doesn't exist. Because if you look in the figure, they show it here, if you approach the origin in figure 2, if you approach the origin along the x-axis, you're going to get a limit of 0. Sorry, you're going to get a limit of of positive 1. And if you approach the origin along the y-axis, you're going to get a limit of negative 1. And so the limit doesn't exist. Okay. Does that make good sense? All right, Ryan. All right. So I'm just looking here. One moment. So of course, most of the surfaces, if you just observe a surface and like let me see here. One moment. For many surfaces, it's going to be obvious that a limit exists. But for some surfaces, a limit will not exist as you approach a point. Usually it's when there's a problem. For instance, that this function. Hold on. Got to be a little careful because at the origin there could be an issue. right? Because the function's not defined at the origin. However, that doesn't mean in example 1 that the limit would not exist, because we know that functions can have limits at a point, but they're not defined at the point. But it's just the fact that you approach the origin from 2 different directions and got different limits. Okay, and really, you know, this is really more theoretical than. I mean, you can get very theoretical with this, but I'm content to just lead you with that in terms of the definition of what it means for a limit to exist. Okay, so like for example, though, let me just ask you this. Let's say that you had the limit as x, y approaches 1, 2. Okay, that's 1, 2 of the function 5x cubed minus x squared y squared. Okay. Would that have a limit? Would this have a limit? Okay, Diodot says yes. What would it be? Good. Good. I'm hearing good answers here. It would equal 1. So let me ask you, is this function continuous at 1, 2? Is it continuous? Yeah, there's no issue with being undefined, something being undefined. This is a continuous function for all x, y values. It's certainly continuous at 1, 2, and so you can substitute in 1, 2, and get the limit. And you learned how to do that. So really the ideas behind finding limits are in a sense they're similar to what you learned. It's just now when you find a limit, you have to consider, you know, if you have let me just phrase it the way I want to phrase it. If you have, you know, you have your x and your y-axis, okay, and again, let's say, you know, you're talking about the origin. Well, for the limit to exist, any approach going into the origin on that surface, if you approach the origin, then from any direction, the surface will have to have the same value. The limit of the surface, the limit of the function would have to be the same. Are there any questions on this? Okay, let me stop the recording.